The objectives of this video are to distinguish the type of hydrocarbon and be able to name them according to the UPAC rules. And also we must recognize functional groups according to their structures. The UPAC is the International Union of Pure and Applied Chemistry. It is an international scientific organization, not affiliated with any government. The UPAC strives to advance chemistry, in part by setting global standards for names, symbols, and units. Nearly 1,200 chemists are involved in UPAC projects. Naming hydrocarbons is very important because maybe you can have an alkane like C4H10 and you can write this with different structures. So naming it gives each structure an identity and it makes each hydrocarbon unique. Hydrocarbons are compounds made of hydrogen and carbon. They are classified in alkyls and aromatics. Then the alkyls are divided depending on the type of bond they have, which are alkanes that have one single bond and are saturated, alkenes which have one double bond, and alkynes that have one triple bond and are unsaturated.
Okay, so after we just saw how hydrocarbons are classified and there are alkanes, alkenes, and alkynes depending on the type of bond they have, I'm going to show you how to name alkanes according to UPAC rules. But first, let me tell you what alkanes are. Alkanes are hydrocarbons that contain carbon and hydrogen only and have single bonds. That is what distinguishes them the most, that they have single bonds as we have right here. They only have one bond. So now I'm going to show you the UPAC rules and how to name them. Step number 1 is observe the bonds, which are single in this case, so they are alkanes. Step number 2 is determine the longest chain of carbons. Step number 3, number the carbons in that parent chain. Step number 4, identify the alkyl groups or substituent groups and name them using the prefixes and suffixes. We can see that we have the prefixes meth, eth, prop, but, pent, hex, ect. And you can see that only the first 4 are the ones that you really have to learn. Then the next ones are like pentagon, hexagon, heptagon, octagon, like quadrilaterals. And then the suffixes are ane because they are alkanes and il because it is an alkyl group. Then we go to the next step, which is writing the complete name of the whole structure you are given. Okay, so now I'm going to show you an example on how you can name the alkane according to the UPAC rules. So step number 1, observe the bonds. You can see that all the bonds here are single, so in fact it is an alkane. Step 2 is determine the longest chain of carbon atoms. We can start counting whichever way we want. It can be 1, 2, 3, 4, 5, 6, or it can be 1, 2, 3, 4, 5, 6. So whichever way we will have 6 carbon atoms, but the easiest way is to go with the horizontal. So we're going to circle the parent chain we have and then go to the next step, which is number the carbons in the parent chain. In order to do this, you have to keep in mind that you have to put the lowest number on the alkyl groups. So what I mean with this is, if we start numbering this way, it will be 1, 2. The first alkyl group will be in carbon number 2, and if we start here, it will be 1, 2, 3. The first alkyl group and carbon number 3. So we can see that the lowest number is 2, so we are going to start numbering in this way. So it will be 1, 2, 3, 4, 5, and 6. Now let's go to the next step, identify alkyl groups and name them. Here we have the first one. We only have 1 carbon, so it's methyl. And we just write it down here, methyl. Over here we have 2 carbons, which is ethyl. And now the next step is to write the complete name. The first thing you have to do is write the numbers of the alkyl groups. So you have to do it in alphabetical order. Since ethyl comes before methyl, it will be like this: 4 hyphen ethyl, comma 2 hyphen methyl. And since we have in the parent chain 6 atoms, it will be hexane. So the name for this will be 4 hyphen ethyl, comma 2 hyphen methyl hexane. Okay, so now we are going to go with an easier example than the one I just showed you. And here we have the chain, and we're going to follow the UPAC rules again. First, observe the bonds. We can see that all the bonds are single, so this is an alkane. Second step is to determine the longest chain of carbons. We're going to start counting them. 1, 2, 3, 4, 5. And we can see that there are no branches in this chain. It's only one chain, so we're going to circle the parent chain we have. Then the next step is to number the carbons in this parent chain. So since there are no alkyl groups, there are no branches, we can number whichever way we want. 1, 2, 3, 4, and 5. The next step is to identify alkyl groups. We don't have any alkyl groups, so we're just going to skip this step and go to the next one. Use the prefix and the suffix to name all of this structure. We can see that we have 5 carbons, so we're going to use the prefix pent and the suffix ane. So all of this has a name and it's called pentane. Okay, so now I'm going to show you another quick example on how to name the alkanes. Here we have the chain. Let's look at the steps. Number 1, observe the bonds. The bonds are single, there is an alkane. Step number 2 is determining the longest chain of carbons. Now let's start counting. We can go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. We can see that the longest chain is the one that is horizontal. So we are going to circle the parent chain. Next step is to number the carbons in the parent chain. Remember that we have to number it in order to have the alkyl groups with the lowest numbers. So if we start numbering on this way, it will be 1, 2, 3. On carbon number 3 there is the first alkyl group. Or if we start this way, it will be 1, 2, and on the second carbon we have the first alkyl group. So we can see that we need to start numbering in this way. So it will be 1, 2, 3, 4, 5, and 6. Now let's go to the next step. It is identify the alkyl groups and name them. Here we have 1 carbon on the first alkyl group, so it is a methyl. And then over here we have another methyl since it only has 1 carbon. And there is a way to name this, since we have, like I said in the beginning, the same alkyl group more than once. So what we have to do is first put the number on the carbon that we have this alkyl group. So this carbon 2 and carbon 4, so it's 2, 4. And then since we have the same alkyl group twice, we will use D as a prefix. So we will put D methyl, since we have 2 methyl groups. And then we will put the name of the parent chain. Since we have 6 carbons, we will use hexane. So the name of all this structure will be 2, 4 hyphen dimethylhexane. Okay, so now I'm going to show you how to draw this structure that we have written here. This is an alkane, and I'm going to show you how to draw it like the one I just showed you previously without the carbons. I'm going to show you how to write it. So the first thing we have to do here, we don't have to follow these UPAC rules. These are just to name the alkanes. To draw them, there are specifically no rules, but there are some steps you can follow. First, you can see that it says that this alkane is an hexane, which means it has 6 carbons. So the first step is to start writing the 6 carbons. So we have 1, 2, 3, 4, 5, and 6 carbons. Now, here we have diethyl, which means we have 2 alkyl groups that are ethyls. These 2 alkyl groups are located in carbon 3 and carbon number 4. We can name the carbons, but I'm not going to count them now. We're just going to count them like this. We don't have to write it. So we can see that on carbon number 3 we have the first ethyl group. 1, 2, 3. In here we have a branch. Now ethyl means 2 carbons, so we have to write it like this. 1 carbon, 2 carbons. Now we have on the 4th carbon, we have another ethyl group. So we need a branch here, 1 carbon, another carbon. Now we basically just drew what we have here. We just have to fill in the carbons, and we just start writing it. CH3, CH2, here we have CH, CH2, CH3, CH3, CH2, CH, CH2, and CH3. In order to write this, you have to remember that carbons can only have 4 bonds. So, for example, here we only have 1 bond, so we have to put CH3. In this case, we have already 3 bonds, 1, 2, 3. So we need to have an H here. Here we have 2 bonds, so we put CH2 in order to complete the 4 bonds. Okay, so now I'm going to show you another example on how to draw the alkane. This is a much simpler example. We only have hexane, we don't have alkyl groups. So since it is hexane, it means we have 6 carbons, so we are just going to draw 6 carbons over here. 1, 2, 3, 4, 5, and 6. Now this is basically it. We only have to fill in with hydrogens. As I just told you, carbons can only have 4 bonds with hydrogens. So here we have already 1 bond, so it is CH3. Here we have 2 bonds, CH2, 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 and CH3. So now I'm going to show you another example on how to draw alkanes. We have to draw all of this. It seems very difficult, but really it is very simple. We have 4-ethyl-3,4-dimethyl octane. Now we may see this as very complicated, but since we saw in the last examples, we need to start over here. We can see that we have an octane, so we have to draw first 8 carbons. So it is 1, 2, 3, 4, 5, 6, 7, 8. Now we already have octane. Now if we can start over here, we can see that on carbon number 4 we have the first alkyl group, which is an ethyl. So it is 1, 2, 3, 4. Here in the 4th carbon we have an ethyl group. Ethyl, according to these prefixes, it is 2 carbons. So here we have to do it like this: 1 carbon, 2 carbons. That's it. Now we have that on carbon 3 and on carbon 4 we have methyl groups. This is why it is called dimethyl. So in carbon 3 we have a methyl group. Methyl stands for 1 carbon. So on carbon number 3, 1 carbon. Carbon number 4, since we already have an alkyl group over here, we just put it on the right side. Sorry for that. I was saying that we can put the carbon over here on top of this one, since we already have this space occupied by the ethyl group. So we just put over here the other carbon, and that's it. Now we just have to fill in with hydrogens. As I told you previously, carbon can only have 4 bonds, so we just start putting the hydrogens. Over here we have 1 bond, so it is CH3, 2 bonds, CH2, 2 bonds again, CH2, CH2. In this carbon it is special since it already has 4 bonds. We don't put any hydrogen, it just stays like that. We have passed to the next carbon. We have 3 bonds, so it's CH, 2 bonds, CH2, 1 bond, CH3. Over here we have CH3, CH2, since we have 2 bonds, CH3, and on top here we have CH3 again.
Hello guys, today I'm going to teach you how to name an alkene, and the first step is to choose the longest chain containing the carbon double bond. After that, we number the carbons of the parent chain so that the double carbon bonds have the lowest number possible. If the double bond is equidistant from each end, number so that the first substituent has the lowest number. Next, we indicate the double bond by the number of the first alkene carbon. Then, we write out the full name, numbering the substituents according to their position in the chain and listing them in alphabetical order. Hello again, this is our first example of naming alkenes. As you can see, I already chose the longest chain containing the double bond, and this step is very simple and you shouldn't have troubles with it. Then, we must start numbering the parent chain, but make sure that the carbon double bond has the lowest number possible. Well, I numbered the chain in this way because the distance from each side is equal, but here we have the closest substituent. Well then, we just give the numbers of the substituent first and list it in alphabetical order. Here we got 2-methylpentene. And this is the name of this. Well, here we have another example of naming an alkene. And I already choose the longest chain and numbered it. So here we have an example. We first name the substituent, which is a methyl, and select its position. And last, we just give the name of the longest chain, which contains seven carbons. And this gives the name of heptane. And that's all for this alkene. And this is the last example of naming an alkene. It's very simple. I already chose again the longest chain and number the chain. So I just need to give the name of the substituent and then the name of the chain. The substituent is in the third position, so I just need to give the position and the name. It's 3-methyl, the substituent name, and I just give the name of the chain now. As the chain has 5 carbon atoms, the suffix we'll be using is pent, and due to the double bond, the prefix will be in. So finally we got 3-methylpentene.
Now we will continue with alkynes. Alkynes are hydrocarbons that contain one triple bond between carbon and carbon, and its general formula is CnH2n-2. These are the steps to name alkynes based on the UPAC system. First, we have to identify the longest chain. And this longest chain must include the triple bond. So this is the triple bond, and this is the longest chain. Then write the alkyne name of the longest chain. Since there are 1, 2, 3, 4, 5 carbons, this is a pentane. Then number the carbon atoms starting from the end nearest a triple bond. This is a triple bond, so we start with 1, 2, 3, 4, and 5. Then give the location and name of each substituent and alphabetical order as a prefix to the name of the chain. This is a methyl group, and this is carbon 4, so it will be 4, methyl 2, pentane. This is another example, and we're going to name this molecule as we did here. So first we have to find the longest chain, the one with the triple bond, so it will be this. And write the alkyne name of the longest chain. So this is a 1, 2, 3, 4, 5, 6, 7. This is a heptane. Then number the atoms starting from the end nearest to a triple bond. But we here have a double bond, and the double bond has precedence over the triple bonds. So we will start here. 1, 2, 3, 4, 5, 6, and 7. And then give the location and name of each substituent, alphabetical order, as a prefix to the name of the chain. This we have 1 and 2 methyls. The first methyl is in
carbon 2 and the second in carbon 4. So it will be 2, 4 dimethyl, and since there are 1 and 2 multiple bonds, we have to write it like this. F, because it's octane, and the double bond is in carbon 3, so it will be 3 in, and the triple bond is in carbon 5 ion, and this is it. And this is example number 3, and we are going to solve it like we did before. So here is the triple bond, here is the longest chain. And then we have 1, 2, 3, 4, 5, 6 carbon. This is hexane. And then here is a triple bond. 1, 2, 3, 4, 5, 6. This is a ethyl group, and this is a methyl group. The ethyl group is in carbon 3 and the methyl group is in carbon 4. So it's in alphabetical order, then ethyl is first. So it will be 3 ethyl, 4 methyl, and the triple bond is in carbon 1, 1, hexane. Now we continue on how to draw structural formulas for alkynes. This is a structural formula, so we will do it, this example in here. First, we have to identify this, the pentyne. So we will draw 1, 2, 3, 4, and 5 carbons. Then the triple bond is in carbon 2, so this is carbon 2 and this is the triple bond. And the methyl is in carbon 4, so 1, 2, 3, 4. And then each carbon must have 4 bonds, so we will complete them. This carbon just have 1 bond, so this is 2 bonds, and just like here. And then this carbon have 1, 2, 3, 4 bonds. This 1, 2, 3, 4 bonds. This 1, 2, 3, 4, and this 1, 2, 3, 4, and this 1, 2, 3, 4. This is the condensed structural formula, and then the expanded structural formula will be like this. 1 carbon with 3 hydrogens, and it's 4 bonds, and the same here, the same here, and the carbon with its hydrogen, and another carbon with its 3 hydrogen, and another carbon with 3 hydrogens. And this is the same like this. This is the expanded
structural formula, and this is the condensed structural formula. Now we'll continue with two more examples. So this is a heptane. 1, 2, 3, 4, 5, 6, and 7 carbons. In the carbon number 3, it has a double bond. 1, 2, 3, double bond. And in the carbon number 5, it has triple bond. 1, 2, 3, 4, 5. The triple bond. In the carbon number 2 and 4, it has methyls. So carbon number 2 and carbon number 1, 2, 3, 4. And then we have to complete the 4 bonds. Like this, and this, 1, 2, 3, 4. And 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 4. This is the condensed structural formula. And then the expanded structural formula. 1, 2, 3, 4, 5, 6, and 7. In the carbon number 3, the double bond, and in the carbon number 5, the triple bond. And then in carbons 2 and 4, and the methyl. 2, 1, 2, 3, 4. And then we draw the hydrogens. 1, 2, 3, and 4 bonds. 1, 2, 3, and 4. 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 1, 2, 3, 4. 1, 2, 3, 4. And this is heptane. And then we'll continue here with the hexane. So 1, 2, 3, 4, 5, 6 carbons. In the carbon number 1, there is the triple bond. In the carbon number 3, there is ethyl. 1, 2, 3, and the ethyl. In the carbon number 4, the methyl. 1, 2, 3, 4, the methyl. So we will complete the 4 bonds, and 1, 2, 3, and 4. 1, 2, 3, and 4. 1, 2, 3, 4. 1, 2, 3, 4, and 1, 2, 3, and 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 4. And finally 1, 2, 3, and 4. This is the expanded structural formula, and this is the condensed structural formula. All we have to do is count the hydrogens and put it in the carbon like this. CH with its triple bond, and C with 1 hydrogen, and here the ethyl with 2 hydrogens, and the other carbon
with 3 hydrogens, and another carbon with 1 hydrogen, and another carbon with 3 hydrogens, and another carbon with 2 hydrogens, and the last carbon with 3 hydrogens.
Now we will continue with aromatic compounds. Aromatic compounds are compounds that contain benzene. Benzene has a 6-carbon ring with only 1 hydrogen atom attached to each carbon in the ring. The general formula for aromatic compounds is CnH2n-6. These are the steps to name aromatic compounds based on the UPAC system. Number 1. Identify the benzene group. Number 2. When a benzene ring is substituted, it is named phenyl. Number 3. When benzene has only one substitute, the ring is not numbered. Number 4. When there are 2 substitutes, the benzene ring is numbered to give the lowest number to the substitutes. There are prefixes that are used to give the position of the substitutes, like for example, ortho indicates a 1,2 arrangement. Meta indicates a 1,3 arrangement, and para indicates a 1,4 arrangement. First, we have to identify the benzene group, and this is a methylbenzene since its substitutes are methyls. Then we have to number the carbons, and we will do it like this. The methyl groups of this methylbenzene are in carbons number 1 and 2, so the name of this compound will be 1,2-dimethylbenzene. Like I said before, when benzene is a substitute, it is called phenyl. So since the benzene ring is in carbon number 2, the name of this compound will be 2-phenyl-hexane because it has 1, 2, 3, 4, 5, 6 carbons. When benzene only has one substitute, the ring is not numbered, so this compound will just be propylbenzene. One, 2-dimethylbenzene. First, we draw the benzene ring. Then, since this is a dimethyl, there are 2 methyls in carbon 1 and 2. So we draw the carbons 1 and 2, and we put the methyl there. And then we draw the ring inside the benzene, and that's all. Propylbenzene. First, we draw the benzene ring. Then, since this is just propyl, then we can draw the propyl group wherever we want, just like here, and that's 2-phenylhexane. First, we have to draw the 6 carbons, and then in the carbon number 2, we draw the phenyl, the benzene ring, and then we just have to add the hydrogens, and that's all.